guys, this is part 2 for 17.3 sample exercises. So let's get started. I'm going to do this in a different color so you can see this. So the first part, just a very, very quick recap. First one was 49 milliliters of sodium hydroxide in a titration, which means that there was less sodium hydroxide per mole, excuse me, less sodium hydroxide per mole than there was hydrochloric acid, which means that there was a little bit of acid left over, which is why our pH is so low down here to pH number 3. Okay, so that means that there is acid left over, pH was less than 7, it's an acidic solution. Now look what happens here when I have 51 milliliters of sodium hydroxide. I'm going to do the same thing that I did before. There's no change. It means that for the number of moles, that equals the concentration times volume. I changed my volume to be in liters, so it looks just like the one above, except my concentration is the same, except this time instead of 0.049 liters, I have 0.051 liters. And that does make a little bit of a difference because what it ends up being then would of course be, where are we at here? 0.0051 moles of sodium hydroxide. Now that means that I'm going to end up with a little bit of sodium hydroxide left. I'm going to go through the same procedure I did last time. I'm going to show you the HCl plus NaOH. And then we're going to subtract the moles to see what comes up. Okay, now in this situation, I still have the same number of moles that I did on the other side for the last one, which was when I take the number of the concentration times the volume, I end up with 0.0050 moles, and here I have 0.00510 moles, and what I do is I subtract the smaller of the two to find out what happens. I get 0 for hydrochloric acid, which means that now I have just a little bit, oops, there we go. I have just a little bit then 0.0010 moles of hydroxide, like that. Okay, now that I have that much of the sodium hydroxide, 1 times 10 to the negative fourth. Okay, so 1 times 10 to the negative fourth is the number of moles I have. I divide it by the total. Now the total is going to be a little bit different because before it was 0.05 liters for the acid. I'm talking about up here. It was 50 milliliters plus 49 milliliters. Now it's going to be 50 milliliters plus 51 milliliters, which means that what I'm going to have here, let me just write this out so you guys can see what's going on. 50 milliliters plus 51 milliliters is going to equal, obviously, 100, where are we at here? 101 milliliters, which is going to be 0.101 liters. And that's what goes on the bottom here. Like that. Now that I have that number of moles divided by milliliters, I'm going to end up with a concentration of hydroxide of approximately very close to 1.0 times 10 to the negative third. That's the concentration of hydroxide. That means that my pOH is equal to a 3, and to find pH, I simply take 14 minus the pOH, gives me the pH. Hang on, I need to scroll down just a little bit more. Which means 14 minus 3 equals a pH equals 11. Look at the difference between pH of 3 when I have 1 milliliter less than equivalence point, and pH of 11, 1 milliliter over What a huge difference that is, 3 and 11. Okay, so that's what you're supposed to look out for. Let me just take a quick look at this. And that's going to be part 3. Part 3. Okay.